Hello everyone, we're looking at question 4 of 2008 paper 4 9702. A part says write down an equation to represent the first law of thermodynamics in terms of the heating Q of a system, the work done W, and the increase in the internal energy. Now we have to look at this key point that it is done on the system and we are heating the system. So there are two things: either the work is done by the system. If the work is done by the system, that becomes negative. But if the work is done on the system, then you have to make sure that you write positive. Positive is for on system. The same goes for Q as well. If the thermal energy is being supplied to the system, that's positive. And if it is negative, that means it is emitting heat. So they say in terms of, we have to find this, I'll write equals plus Q plus W, because it is done on the system and heat is provided to the system. Moving on towards the B part, that says the pressure of an ideal gas is decreased at a constant temperature. So many keywords. Number 1, ideal gas. Number 2, constant temperature. Explain what change, if any, occurs in the internal energy of the gas. Now, there are a few things that I will tell you that is going to make this question a lot easier. Number 1 is, whenever you look at the word internal energy, internal energy always comprises of two things. Number 1, the potential energy, which is due to the intermolecular forces between the particles, and number 2, the kinetic energy. Number 1. Number 2 is, whenever we have ideal gas, you have to realize the internal energy of ideal gas only and entirely and solely depends on temperature. Why? Because ideal gas, because there is this assumption that we make for ideal gas that there are no intermolecular forces between them. So if there is no intermolecular forces between them, the entire purpose of potential energy is the intermolecular forces. So if intermolecular forces are not there, the potential energy is not there, so it is entirely dependent on the kinetic energy. And one more point is, kinetic energy is dependent on temperature. As you increase the temperature, the kinetic energy increases as well. Now, it's decreased at a constant temperature. Now, we know the internal energy only depends upon the kinetic energy because there is no potential energy, and kinetic energy depends upon temperature. To make it more simpler for you, we have ideal gas, it only depends upon kinetic energy. Why? Because there are no intermolecular forces between the particles of ideal gas. And then this leads to kinetic energy is only dependent upon temperature, and the ideal gas itself is only dependent upon temperature. So if there is constant temperature, if temperature is not even changed in the first place, we will say there is no change in the internal gas. So how do we write this? There is no change in the internal gas because at a constant temperature the kinetic energy remains constant, because at a constant temperature the kinetic energy remains constant. And since it's for 3 marks, you will have to mention about the potential energy as well, and you can say that the potential energy also remains constant. because there are no intermolecular forces between the particles according to the kinetic theory of gases. And this will be your answer for 3 marks for the D part. And this is it for question number 4.